So one majorly important and awesome thing that classes can do that structs can't is the ability to subclass. So when we create subclasses, they are able to inherit all of their properties and methods from their superclass. So let me show you with an example. So we're going to create a new class here for an animal. Okay, so we'll say class animal. Let's give it a few properties. We'll say species. That's going to be of type string, number of legs. It's going to be of type int, and let's do whether it has a tail or not, and that's going to be a bool, right? So remember, because this is a class, we have to create our own initializer, okay, and we have to initialize each of our properties. So we'll say init, and we have species of type string, we have number of legs of type int, and we have has tail of type bool. Then in the body here, we're going to say self.species is equal to species. Self.number of legs is equal to number of legs. Self.hasTail is equal to hasTail. Okay, and then let's go ahead and create a method on this. Okay, so remember, a method is a function that all instances of this type will have access to. Okay, in this case, I'm going to create a method called vocalize. So we'll do func vocalize, and we want it to print I'm a whatever species they are. Okay. Okay. So let's go ahead and let's create an instance of our animal. Okay. So let's do we'll do my dog. Okay, my dog's Stark. His name is Stark. So let's say let Stark equal animal. Okay, he is a canine. He has 4 legs, and has tail is equal to true. Okay, so now that we have our instance of our animal class, okay, I have access to those properties and methods. So let's go ahead and call Stark vocalize. Okay, if we run this code, we see that Stark says I'm a canine. Okay, well, what if, it's true that Stark is an animal, but what if I want to create a class that's a dog, that's like a little bit more specific to Stark in this case? Okay, well, Stark is still an animal, so I want access to all of these different properties because these are still important things to classify when creating an instance of Stark. But maybe I want to create a dog subclass. Okay, well, what I can do then is, in order to inherit all of these things, I'm going to make my dog class a subclass of animal. Okay, so in this case, let's go ahead and say class dog. And in order to make something a subclass, we're going to put a colon here and then type in the superclass, which is going to be animal. Okay, so this syntax right here is creating a new class called dog, and it is a subclass of animal. Okay, so we'll go ahead and we'll create our open braces. And now we're going to think of some properties that are more specific to a dog. Okay, so we'll say name, okay, breed, which will be of type string, and let's put color here. Okay, so because we have a class, I still need to use my initializer, or I need to create an initializer. Okay, and so we've got our name here of type string, we've got our breed of type string, and we've got our color, which is also of type string. And we're going to set all the selves equal to the arguments, right? So self.name equals name, self.breed equals breed, and self.color is equal to color. Okay, so we see another compiler error here that says superinit isn't called. Okay, so when we are creating a subclass, in our init method, we also need to call superinit. Okay, so because this is a subclass, we need to make sure that all of the properties in our superclass here have been initialized as well. Okay, so here I'm going to call super, which is, our superclass, called the super initializer. And then you see now it wants me to pass in all of these properties here for species, number of legs, and has tail, right? Because those are all the properties that are required in initializing an instance of animal, okay? So in this case, well, lucky for us, all dogs are canines, okay? So, and all dogs have 4 legs, and we can probably say that has tail is equal to true in pretty much every case, okay? So now we have our initializer for the dog's properties as well as our animal superclass, okay? Well, let's go ahead and, when we called Stark vocalize here, it printed out I'm a canine. But dogs can't really talk, right? They just bark. So maybe I want to override my vocalize method, okay? So when I'm creating a subclass, I can override any of my methods and properties. Okay, so in this case, I'm going to override vocalize so that whenever an instance of my dog is vocalized, it's going to print out woof, woof, okay? So instead of printing out I'm a canine, in the case of a dog, I want it to print out woof, woof. So I use this override keyword here to override the function in my superclass, okay? So override func vocalize. So now let's go ahead and let's clear this out. And let's create a new instance of Stark. Okay, so let Stark equal, and Stark is of type dog, right? So now when I create an instance of my dog, I'm only required to instantiate the name, breed, and color, because my species, number of legs, and has tail have already been instantiated, right, in the super init. So I don't need to pass those things in again, because they already inherited all of those initializers from the superclass, okay? So in this case, we can say Stark, our breed, we could say he is an Alaskan Malamute, and color is black. And now, if I call Stark.vocalize, we'll see that instead of printing out I'm a canine, he's now printing out woof woof because we overrode that function for my dog type. Okay, and so now if I access the other properties on Stark, if we do Stark period, we see that I have access to breed, color, and name, but I also have access to all of those properties on the superclass. Okay, so has tail, number of legs, and species. So if I print out Stark.species, we see that Stark is a canine. And remember, I didn't need to set that specifically because it received that species in our super init method. Okay, so let's do another example to really hammer this down. So let's create a class for a building. Okay, so we'll say class building here, and we'll give it a few properties. We'll say number of floors of type int, purpose of type string, and let's give it some building material, which is also going to be of type string. Okay, well, let's create the initializer for this. So we need to initialize number of floors of type int, the purpose of type string, and the building material, which was also of type string. And we'll say self.number of floors is equal to number of floors, self.purpose is equal to purpose, and self.building material is equal to building material. Great, so now we have our building class. Well, I want to create a subclass of building for a house, right? So a house is going to have a more specific blueprint than a building, but I do want my house to inherit all of these properties, okay? So let's go ahead and we're going to define our class here. So we'll say class house, and remember it's a subclass of our building type. Okay, so we'll give the house a few more properties. So we'll say number of bedrooms of type int and has backyard of type bool. So now we're going to use our initializer here, and we need to initialize number of bedrooms of type int has backyard of type bool, and then we'll say self.number of bedrooms equals number of bedrooms, self.hasBackyard equals hasBackyard. And then remember, because this is a subclass, I need to call superinit. Okay, and then for our case, let's say maybe we could change this class to be like a townhome. Okay, a special townhome for a project that we're working on. Okay, so in our case, all of the townhomes have 2 floors. Their purpose is for living, and we'll say that they're all made out of brick. Okay, so now I can go ahead and we can create an instance of our townhome. So we'll say let my townhome equal townhome, and then we just need to pass in the number of bedrooms and whether it has a backyard or not. Okay, so we'll say 3 bedrooms and has backyard is equal to true. Okay, so now if I inspect some of the properties on my townhome using this dot syntax, you can see that even though I only passed in the number of bedrooms and has backyard, I can also see all of the properties of its superclass, so its purpose, its number of floors, and its building material. Okay, so let's see, what are our townhomes made out of? Let's print out my townhome dot building material. And we see that it inherited from the superclass the building material of brick.